Okay, today we're going to talk about domain and range for discrete functions. We're going to use linear functions in mathematical problems, so those are your lines, straight line functions. We're going to determine reasonable domain and range values for real-world situations. Those are the word problems, both continuous and discrete. Today we're focusing only on the discrete functions. We will talk about continuous functions at another time. And we're going to represent our domain and range using inequalities, your less than, your greater than symbols. This is going to be with continuous, so we're not going to see the less than and greater signs today for this lesson. We're going to focus on the discrete domain and range. So let's talk about some vocabulary that you're going to need to be familiar with. The first is domain. So the domain of a relation is the set of all inputs or x coordinates. So domain is just another word that we use in algebra to talk about our x values. You heard me say inputs when we were talking about function notation. Today we're adding another word, domain. So we've got domain, inputs, x values, and then there's another word that you use a lot in science to refer to your x values, and that's the independent quantities. Independent variable, those are also referring to your x values. So one way that I can give you to help you remember all of these words for x is this little acronym, DIXI, Dixie. Domain, inputs, talking about x values, independent. Any of those words could be used in a math test in algebra to be referring to the x values, so you need to make sure that you can recognize those words and connect it back to these are my x's. These are my x values. Now we're going to talk about vocabulary for range. The range of a relation is the set of all outputs or y coordinates. So you've got range, r, outputs. I used outputs a lot when we were using function notation. Y for y values, and then if x is independent in science, y is referring to the dependent variable or the dependent quantities in science. So to help you remember these words, you're going to use the acronym ROYD, R-O-Y-D, and those range, output, dependent, all talking about the y value. So when you put it together, Dixie, Roy, those are going to be 8 letters that should help you kind of connect the vocabulary back to x and y. And once you do that, it does make the problem a little bit easier to solve. So now let's talk about discrete. When I mentioned we were going to find domain and range for discrete functions, what does that exactly mean? Well, a discrete domain is a set of input values, so x values. So it's a group of x's that consist of only certain values. So when you want to figure out if it's discrete, you have to look at only your x values. That's going to tell you if you're going to leave out certain values. So think about when you count people. Are there numbers that you leave out when you count people? Well, yes. Hopefully you're not using negative numbers. You're not saying -1, -2, -3 to count people. And you wouldn't use 0 because you wouldn't have any people to count if you had 0 people. So you start with 1, then you go to 2, then you go to 3, then you go to 4. Notice I'm skipping over all of my fraction numbers between my whole numbers. So I'm not saying 1.5, 2.5, 3.5. I'm skipping over and only using my positive whole numbers. That would make my domain discrete. Here's some more ways that you can identify if your data is discrete. It is the result of quantities you are counting. For example, I count the number of students. I can count the number of desks. I can count the number of cars. Okay? All of those are leaving out numbers in your number system, and you're counting them. In a graph, here's what it looks like. It's going to be a scatter plot, and if you remember, a scatter plot is made up of dots, and it does not have to be positive or negative or no correlation. It's just dots. Discrete equals dots, and they are not connected. If you have to pick up your pencil to make the graph picture, I'm picking up my pencil moving from ordered pair to ordered pair, that makes it discrete. And that is what we are focusing on today. So if your data is discrete because your graph is dots, which means you're only using certain values for your x values, then you will simply list all of your inputs and outputs in squiggly brackets, curly brackets, no repeats. So let's look at some examples to see what does that look like exactly when I start looking at representations. So I've got ordered pairs. So again, I'm looking for my domain, which is another word for x. So now I have to be able to identify which values are x's in my ordered pairs. And hopefully you said that your x values are the first number in an ordered pair. So I'm going to list my numbers from my ordered pair. And I'm going to put them in order from least to greatest. So I've got -6, then -1, then 0, 2, 4. Now, they have to be inside squiggly brackets. So I'm going to put my curly brackets there, and that is my domain for this representation of ordered pairs. Now I'm going to look for the range. And remember, the range, the y values, are the second number listed in an ordered pair. So now I'm going to list my y values in order from least to greatest with no repeats. My smallest is -6, 2, and notice how my 2 is listed twice. I'm only going to list it once in my range list, and then I'm going to go to the next one, 3 and 7. So notice I have 4 range values, but I have 5 ordered pairs. That's because my output of 2 is listed twice, here and here, but I only list it once when I write the range. And that's all there is to it. Now we're going to look at tables. So I want to identify my domain from the table, and again, those are my x values, so I'm going to make some curly brackets. And I want to list my x values. X values are the left column. So I'm going to list all my x values, and 1, 2, 3, 4, up. The 3 is repeated, so I only have to list it once. So 1, 2, 3, 4. And that is it. The range are your y values, and those come from the right column in the table always. And I've got 5, 6, 5 is listed twice, so I only want to list it once. So is my 6 and then 7. So my range values are 5, 6, and 7. Make sure you put curly brackets around those to identify that those are a list of inputs or output values, and that's all there is to it. Now we're going to look at our mapping diagrams. Mapping diagrams are nice because they are listed just like a table. So the left oval is x, which means those are my domain values. And how the mapping diagram is laid out, it's already laid out from least to greatest and no repeats. So all I have to do is copy all of these values in my left oval, and those are my domain values. So -1, 0, 1, 2, and 3. Now I'm going to list my range values. So I want to identify my range. What are my y values for this problem? And my y values being used are 0, 1, 4, and 9. Notice, least to greatest, no repeats listed, makes it really easy for me to identify my range. Okay, graphs. Graphs are, again, connecting the word back to x or y. The horizontal flat axis is your x number line, so all of my domain values are coming off of this number line. So I'm going to start at the left where they get smaller, and I'm going to work my way here. And look, this point has an x value of -3. This point has an x value of -2, 1. This point also has 1, but since I've already listed it, I don't list it again. And now I have this point right here, which has an x value of 4. Again, I had 5 ordered pairs, but only 4 domain values because one of those x values was listed twice. And I don't list any repeats in my domain values. Okay, let's look at our range. Y values, I'm going to list them off the y number line. So all of my y values, all my ranges are coming off the y number line. So I'm going to start at the lowest because I want to go from least to greatest. That is a -4, then a -2, 0. This is a y value of 3. And this ordered pair has a y value of 5. So I want to also draw your attention to the fact that your domain and your range list may not have the same number of values. This has 4 values. The range has 5 values. I need to put curly brackets on there so it's correct. So just because your domain has 4 values listed does not mean your range will have 4 values. You list all of the y values and all of the x values with no repeats. All right, let's look at the last 2 examples.